So let us come to the parsing technique part 2. In the previous part 1 we had discussed about the top down parsing. Here we will be discussing about the bottom up parsing, how bottom up parsing is done. So in this case the parsing is constructed from the bottom up to the root of the tree, that means from leaf to the root of the tree. So in this process all the input symbols are placed in the leaf node after successful parsing. Now here we have to understand some few things which are there, what is called as pruning or handles and pruning. Now if you find the crucial task in bottom up parsing is to find a substring that could be reduced by appropriate non-terminal, such a substring is called as a handle. Now to understand this, let's look at the grammar. E derives E plus E, E derives ID. Now consider this string, suppose ID plus ID plus ID, and the right mode derivation is given by E derives E plus E. So this E is here, you notice the bolt which is marked as bolt. So E plus E, this E can be expanded as E plus E again, this E can be changed to ID due to the rule, again this E can be changed to ID due to the rule, again this E can be changed to ID due to the rule. So finally we get ID plus ID plus ID. Now this should be ID plus ID plus ID, so let's interpret that as ID plus ID plus ID. Now to look at, if you look at a table, then we can see that the ID plus ID plus ID, this ID will be changed to E, so ID is called as a handle, and this ID has been changed by this production, that is ID has been changed to E, so ID is called as a handle. So again this ID is the second one, this ID is the handle which is changed to E, this ID is the third one which has been changed to E, then E plus E is changed to E, and E plus E is again changed to E. So the process of detecting handles and using them in reduction is also called as handle pruning. So let us come to the first type of, let us come to the top down parsing. The first type is called as the shift reduce parsing. So it attempts to construct a parse tree from leaf to root. It requires the following data structure. It requires an input storage and a stack for storing and accessing the left hand side and right hand side of the rule. So this is the initial configuration we should always have. It should consist of a stack. So the initial configuration in the stack consists of a dollar, and the input will consist of a string W with an ending symbol which is called as dollar, and the final configuration should consist of the starting symbol S in the stack, as in the input it should be empty. Empty means only dollar will be present in it. There are 4 actions which we have to see while using shift reduce parsing. One is called the shift. If we shift the next symbol on top of the stack, that means we bring it from the input and shift it to the stack, then it's called as a shift. If there is a handle for it, then it is called that means we change it to the if there's a handle and change it to a new production, then it's called as a reduce. If it reaches the end of parsing or the completion of parsing, then it's called as an accept. And if none of them is working, neither a shift can be done, neither a reduce, neither an accept, then it becomes a error. Then it will go for an error reporting. Now let us see an example of shift reduce parsing. Now consider the grammar S derive S plus S and S derive ID. So you can see that how it performs using the shift reduce parsing. First of all, in the stack there is a dollar, as I told you in the initial configuration there is a dollar, and the input is ID plus ID plus ID. So you can see that the input is ID plus ID plus ID with a dollar in the last. So first of all, $ID is shifted into the stack, that is why it's called as the shift. Then id matches with s, so it has been changed, id has been changed to s, so it is a reduced. Again you take plus and bring it here, that is a shift action. You take id, it is brought here, that's a shift action. Now id, there is a match with the grammar s, so it is a reduce action, so it's written as reduce. Again that plus comes here, again it's a shift. Again id comes here, it's a shift. Again there's a match id, so there's a match with this id, so it's a reduce action, so this one. Again there is s plus s, so s plus s derives s, so it's a reduce action, so it's reduce. Again s plus s, there's a grammar, s plus s gives you s, so it gives s. So if it is the starting symbol s and the input is empty, then we call it as accept, because as the rule says that the final configuration should consist of $, the starting symbol, and the input should be $. So what we have here is, in the stack there's a $s, and the input buffer is $, so we call it as an accept. So this is how a shift reduce parsing works.